Today's lesson will be over graphing linear equations using a T-chart. An example of an equation in two variables is 2x plus 5y equal 8. It's got two variables, one variable representing the distance on the x-axis and the other variable representing the distance on the y-axis. A solution of an equation in two variables, x and y, is an ordered pair, x comma y, that produces a true statement when the values of x and y are substituted into the equation. Basically, all that is saying is if we substitute an x value of a coordinate and a y value of a coordinate into this equation, and the equation produces a true statement such as 7 equals 7, 5 equals 5, or something like that, then that ordered pair is a solution to the equation. And there are many solutions to equations with two variables. Let's look at this example. It says, for example, -1, 2 is a solution to the equation because it produces a true statement. Well, let's check it out. Let's see if it is. If I take this equation, 2x plus 5y equal 8, and substitute in -1, 2 into this equation, remember x comma y for a coordinate, so substitute -1 in for x, and 2 in for y, and I produce a true statement, then -1, 2 is a solution to the equation. So 2 times -1 is -2, 5 times 2 is 10, -2 plus 10 is 8, so we have 8 equal 8. This is a true statement, which means -1, 2 is a solution to the equation. Now we want to determine whether or not each ordered pair is a solution to the equation 2x plus y equal 11. We have three ordered pairs, 2, -3, 8, -5, and 1, 1. Let's check and see if each of these are a solution. So let's take 2, -3 and plug it into this equation. That's 2 times 2 plus -3 equals 11. 2 times 2 is 4. Plus a negative means -3 equals 11. 4 minus 3 is 1. 1 equals 11. Is this true? No, it's not. So this right here is not a solution. 8, -5. Let's try that one out. We plug it in. So we got 2 times 8 plus -5 equal 11. 2 times 8 is 16. Plus a negative means -5 equal 11. 16 minus 5 is 11 equal 11. This is true statement. That means 8, -5, this ordered pair, is a solution to the equation. Now let's try 1, 1. If we plug 1, 1 in, that's 2 times 1 plus 1 equals 11. 2 times 1 is 2, plus 1 equals 11. 2 times 1 is 3. 3 does not equal 11, so this is not a solution to the equation. Now we're going to look at the 5-step method of graphing using a T-chart. A T-chart can be used to graph any equation with two variables. We're going to go through a series of examples where we use each of these steps, and you'll be able to see that these steps work for anything, and if you follow the steps, you should be able to graph using a T-chart. Now we're going to graph x minus y equal 3. Let's go to step 1, make a T-chart. Step 2, pick our values that we want to plug in for x. I will always plug in, or at least most of the time, -1, 0, 1. Step 3, actually take each value and plug it in and solve the equation for the corresponding y value. -1 goes in for x, so I get -1 minus y equal 3. Add 1 to each side. -y equal 4. Divide by -1. and y equals negative 4. Corresponding y value is negative 4. Take 0. We're going to take 0, plug it into the graph. If I plug it in, that's going to give me 0 minus y equal 3. So that's just negative y equal 3, which means y equals negative 3. You divide by negative 1 on each side. Now we take 1, plug it in. We have 1 minus y equal 3. Subtract 1 on each side. That leaves us negative y and 2. Divide by negative 1 on each side. And y equals negative 2. Negative 2 goes here. That's the other point. Now we need to graph each of these ordered pairs. We got negative 1, negative 4. Negative 1 says to go left on the x-axis, negative 1, and down 4. 1, 2, 3, 4. 0 means to stay right at the origin. Y being negative 3 means to go from 0 and down negative 3. 1, negative 2, go over 1, down 2. Notice the 3 dots are lining up. Now all I have to do to connect my dots is draw a straight line, as straight as you can make it, right through. That's graphing using a T-chart. Now we're going to graph y equals 1/2 x minus 5. Step 1, make a T-chart. X and the corresponding y's. Pick your points that you want to plug in for x. Now we have a fraction here, so it's pretty important to pick the correct points to make it so that you don't have to deal with fractions this whole time. Right now we have 1/2. The denominator is 2. So if I pick numbers that are divisible by 2, I'm going to cancel out this fraction. Well, I know one number that's divisible by 2 is 2. So I'm going to use negative 2 and 2 for sure. And then I can always cancel out any number by multiplying by 0. So anytime you have a fraction in front of the x, you can just multiply by whatever the denominator is and cancel out that fraction. Or you could multiply by anything that's divisible by 2, such as 4, 8, 10, any of those numbers. So let's plug in negative 2 into our equation and find out its corresponding y. That means y equals 1/2 times negative 2 minus 5. Let's make this over 1. The 2's cancel. That's negative 1 over 1 minus 5. Negative 1 over 1 is negative 1. Get the y equals negative 1 minus 5, negative 6. So y equals, the corresponding y value is negative 6. Now we're going to plug 0 in. Well, if I plug 0 in for x, that's going to give me y equals 1/2 times 0 minus 5, which means this cancels out, so y equals negative 5. Corresponding y value for the x value of 0 is negative 5. Now let's plug in 2. So y equals 1/2 times 2 minus 5. The 2's cancel and I'm left with 1 minus 5. 1 minus 5 is negative 4. So we got 2, negative 4. Now we're going to graph each of these ordered pairs on this graph. Now we're going to look at the ordered pair. Negative 2, negative 6. Negative 2 on the x means to go 2 to the left on the x-axis. 1, 2. Negative 6 for y means to go down 6. 1, 2, 3, 4, 5, 6. Mark it. It's my first ordered pair on my line. 0, negative 5, 0 for the x means to just stay at the origin. So we don't move left or right, we just stay there. Negative 5 means to go down 5. 1, 2, 3, 4, 5. And mark it. 2, negative 4 means to go 2 to the right. 1, 2. Then down 4. 1, 2, 3, 4, and mark it. Now notice that they kind of line up. All the dots line up. Now we just need to draw as best you can a straight line through those points. And you have just graphed using a T-chart. Now we're going to look at some weird ones. Graph y equals 3. You might think to yourself, where's the x values? Anytime you do not see an x value in the equation, that means the x value can be infinite. All right? X is infinite. It means it can be any value of x for this equation. Any value of x works. And all the y values are always 3. Okay, any value for x works, all the y values are 3. Well, if all the y values are 3, I know y is 3 is right here, 1, 2, 3. If all the y values are 3, that means this value right here is a point. This value right here is a point. This value right here is a point. Because any of these points have a y value of 3, which is what it says, y equals 3, and x can be infinite. That means x can be negative 1, x could be negative 2, x could be 0, x could be 1, x could be 2, x could be a billion. Doesn't matter. So anytime you see y equals 3, know that that means the x value is infinite. And y value always has to be 3. And what that's telling you is you have a horizontal line at the value y equals 3. Y equals 3 means it's a horizontal line at y equals 3. Now we're going to look at graphing negative 4, x equal negative 4. Again, x equal negative 4, this is just like the last problem we looked at. X equal negative 4, well, there's no y value. Where's it at? What that means is the y value is infinite. Means y can be anything. Y could be 0, y could be 1, y could be 2, y could be 3, y could be any number. It could be a million. But the x value is always negative 4. It's always going to be negative 4. If the x value is always negative 4, that means, well, if we go to the 4 to the left, 1, 2, 3, 4, if x value is always negative 4, that means it's never going to be anywhere but like here, or here, or here. Because the x value can be negative 4, and the y value can be anything. So we could have negative 4, 0, negative 4, 1, negative 4, 2, negative 4, negative 1. Any of these are good because x always has to be negative 4. That means it's always got to be on this vertical line right here. And the y value is infinite, and it doesn't matter what the y value is. Any of those work. So what that's telling you, when you have x equal negative 4, it's telling you that you have a vertical line at negative 4 because all the y values are infinite and the only value x can be is negative 4.